As an R&D engineer, we must analyze test results such as Muni viscosity, cure time, hardness, and other tests to determine which is most suitable for the product, which in this case study is a bearing. A bearing is a product which permits constrained relative motion between two parts, either linear or rotational. For this product, we must determine which filler is suitable for the properties in processing and also mechanical for the bearing. We will decide either 100% silica or 100% carbon black. Both of these fillers have different surface chemistry. Silica is more prone to aggregate because of its hydroxyl group, which favors filler-filler interaction, so it requires a coupling agent to help it bond better with the rubber. Carbon black, however, does not have a hydroxyl group, so it does not require a coupling agent, but its effect on the rubber depend on its particle size, surface area, structure, and also surface activity.
From the graph, at 0/60 ratio of carbon black over silica loading, Mani viscosity value kept at 58, while at 60/0 ratio of carbon black over silica loading, Mani viscosity value kept at 92. On the other side, at 0/60 ratio of carbon black over silica loading, curing time is 50 minutes, while at 60/0 ratio of carbon black over silica loading, curing time is 11 minutes. Based on the graph for the processing properties, silica compound has lower Mani viscosity but longer cure time, while carbon black compound has higher Mani viscosity but shorter cure time. In our opinion, it is better to have lower viscosity but longer cure time, so that ingredients and other additives can have enough time to properly be distributed in the rubber matrix. From the graph, at 0/60 ratio of carbon black over silica loading, the hardness value is 73, while at 60/0 ratio of carbon black over silica loading, the hardness value is 72. The lowest hardness value can be seen at 40/20 ratio of carbon black over silica loading. For the physical properties, the silica compound produces a higher hardness value than carbon black compound. This is due to a strong interaction between silica fillers that produce a filler-filler network, which is its higher hardness value than carbon black compound, which does not have a strong filler-filler network.
Moving on to abrasion resistance, due to the higher hardness value of silica compound, it is also results in a lower abrasion resistance index. Abrasion resistance is an important factor for products such as bearing. As for example, oil bearing may encounter physical abrasives in the oil. Therefore, carbon black, which is known as a reinforcement filler, is a better filler choice to enhance abrasion resistance for various applications. And finally, for tensile stress, at 300% elongation or M300, carbon black compound has a higher value, which is better to produce products such as rubber bearing. This is because bearing requires to withstand rotation and linear movement. Carbon black compound has a higher M300 value due to its higher rubber filler interaction compared to silica compound, where the silica has a higher filler-filler interaction.
In conclusion, we think it is best to use carbon black as a reinforcing filler because of its higher values in abrasion resistance and M300. There is not a big difference in hardness, unlike in ARI and M300, which is crucial for a bearing. A bearing, for example, an oil bearing inside an engine will require high abrasion resistance because the oil inside the engine may contain abrasive particle, while high damping rubber bearing used for seismic isolation requires high M300 in order to disperse energy in linear movement.